Real-world examples are a great way of putting our learning into context. Simple examples help us to build our understanding of complex ideas like BDD, but seeing these ideas in practice gives us deeper insight. So it's often helpful to see what a real-world example looks like. Real code from a real project solving real problems. So what does BDD look like when done really well? What does acceptance testing in the real world look like? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't already, please do hit subscribe, and if you enjoy the video, hit like as well. I'd like to begin by thanking our sponsors, Harness, Equal Experts, Octopus and SpecFlow. They're all helping us to grow the channel. Their links are in the description below. Please do check them out. If you're interested in learning more about the approaches to software development that I describe, please do check out my training courses. Again, there are links in the descriptions below. In this episode, we will explore BDD style acceptance testing, but in the real world, looking in a real project. My friends at Adaptive, a London-based financial technology consultancy, have given me permission to show you some of their acceptance tests and to critique them. Adaptive take an innovative approach to development, building on and refining some of the ideas that I worked on at LMAX a few years ago. In fact, several of my former LMAX colleagues now work at Adaptive. Adaptive build products for the FinTech space and have created a powerful set of tools to support the rapid development of high quality, extremely high performance trading systems. They've developed and productized some of the ideas that we began work on at LMAX and have created a set of tools and a service mesh or platform called Hydra. Adaptive build extremely high performance, sophisticated reactive systems for their clients on top of this platform. But let's focus in on our topic for today. I want to explore Adaptive's approach to acceptance testing. These tests are whole system BDD style acceptance tests, executable specifications that are used not just to test adaptive systems, but to drive the development of them too. First, some technical context. Hydra provides a blisteringly fast, high quality infrastructure that takes care of pretty much all of the accidental complexity of the system. If you're not familiar with the term accidental complexity, it's based on ideas that were first described in Fred Brooks' influential paper from the 1980s, No Silver Bullet. Links in the description again. The core of our system, the stuff that it must do to achieve its goals, is its essential complexity. Calculating the value of an account, seeing if your missile hit an asteroid, everything else, the stuff that we've got to do because the stuff that's running on our computer. Like storage or responding to a mouse or voice command, communicating over a network efficiently or restarting a failed service or clustering services as backup. All of this is accidental complexity. All the stuff that we have to do, but that users of the system typically don't care much about unless it goes wrong. At LMAX, we did some cool things with service architecture that allowed us to largely separate accidental and essential complexity almost entirely in our system. Adaptive have taken that idea further, and Hydra allows them to build quickly and efficiently very high performance trading systems. Their systems are built from asynchronous services. At the heart of the system, Hydra provides infrastructure to host little bubbles of essential complexity, services that deliver the core behaviour of the application. These services are single-threaded, asynchronous and stateful. Persistence and all of the other accidental complexity is provided by the platform. The core support is from the clustered engine, which hosts the domain logic of the system. This is surrounded by gateways, which translate all inputs and outputs to custom binary asynchronous messages. The whole system is built this way. Practically what this means is that Adaptive can focus on the behaviours of the system that matter most to their customers. Speed, reliability, scalability and efficiency are a given. The platform does the heavy lifting. They employ the kind of two-layer testing strategy that I strongly recommend. Acceptance tests as executable specifications underpinned with lower level, more conventional test-driven development. Here is a simple acceptance test. Here's the setup. Since part of Adaptive's business is to configure and assemble an appropriate suite of platform components to build upon, this specification starts by defining the configuration that will be tested. We're going to need a service engine, an admin gateway, a trading web gateway, an admin API gateway, and a cluster client. In general, I would advise that you work to separate the desired configuration of the system that you want to test from the test itself for acceptance tests. I think that gives you a little bit more flexibility. I'd probably do this in this case by doing something like tagging the test case in some way, perhaps saying that this was an admin only test case or something like that. And then I'd map that admin only to the specification of components that we've just seen in the setup. Then you could hold the definition of the system component somewhere else. And I think that makes it slightly easier so that you could, for instance, spin up lots of copies of the same system to parallelize your tests, or decide to spin up one set of this version of the system and run collections of tests against the same environment, and so share out the costs of starting up the system to be able to run the tests. Next, the case populates the system with some data to get it into the state so that it's ready to test, adding some useful accounts, logging in users, and so on. It's very clear what's going on here. The language is a bit jargony, but mostly it's jargony in a way in which I think non-technical people who understand the problem domain would probably understand. I confess to being a little bit skeptical about the cucumber ID in this list of parameters though. That sounds a bit like test implementation detail leaking out into the test to me. If this kind of setup is common in testing, then I would tend to default a little bit more of this detail in the implementation of the DSL itself so that I wouldn't have to specify it in the test. So instead of all this setup code, I'd have something like login admin user with a few parameters, and that would set up all of these parameters for me. That would create the user, configure their account, some sensible results, and then log them in. But of course, Adaptive are closer to their problems than I am, so my ideas in this context are theoretical. Now we get into the scenario that we're exploring. We log into an account, and again, here is a possible chance to remove anything repetitious. We then deposit $1.23 into the account, and it works. I would remove the technicalities from the wording here. I confess, I am quite picky about trying to hide implementation detail, so I don't really like the wording for some of this. What does API client receives an empty response with status 202 mean to somebody who isn't technical? I'd prefer to say something like account successfully updated instead in the test case, the scenario itself. And then assert somewhere else that the response was empty and reported a status of 202 inside the DSL implementation rather than in the scenario itself. I don't very much like cluster emits broker events either. It doesn't say why that matters and what's the real outcome that does matter here. It's not so clear. This is really talking about the solution and not the requirements, the how rather than the what. I think it's a good idea to try and keep executable specifications focused only on what the system needs to do, not how it does it. I would push this knowledge down into the DSL again and let it understand the how and leave the what to the scenario. Perhaps capture the whole response together in the test case. Write the test from the perspective of the user. In this case, someone who is adding money to their account. The outcome that they care about was that the money was really added. In this example, that means that they get a positive response via the API, sure, but the addition is what really matters. And that should be communicated, presumably to some external system as well. But why not capture that as the desired outcome of the test case? Something like this. account successfully updated, including all of the details of the update. Here's another scenario in this feature. It goes on to confirm that you can't reuse client references issued by the system for a transaction, and so it's a failing case. So they're testing interesting cases here, not just naive happy paths. This test exercised a complex distributed system, but despite my minor niggles, the test cases are pretty simple and pretty clean. Here's an example of the code at the next layer down. This is part of the steps file. This part is pretty simple, and I think you could do a little bit more here to and push some of this stuff one layer down further before getting into the implementation detail, and in this case the use of the API client. Whether my concerns matter or not is probably down to scale. If you have a few tests like this, then maybe the extra abstraction that I would add is overkill. But I think it's low enough cost to be generally worth it. In general, I tend to use internal DSLs, but when I do use Gherkin, my specs files usually look more like this. This makes it very clear that I'm sharing the DSL between spec files that I create, and so that helps. I think that Gherkin's very good, but I think that the tooling can sometimes encourage people to write steps for every feature file if they're not paying proper attention. Let's move on. Here's a second scenario. This one focused on the trading example. It's called place limit order. A limit order is a type of order used in trading. We don't need to go into too much detail, but it's really saying I want to buy or sell something at this price or better. We begin with similar setup to before. A slightly different collection of services this time, and a few differences in the setup for the admin account too. Again, I wonder if you could abstract some of this setup a bit more so that there was less boilerplate to get the test going. The scenario though is much cleaner. Again, there's a fair bit of trader jargon in here, but I can assure you that in trading, this is the language of the problem domain. So that's absolutely fine. This example raises an interesting question. In institutional algorithmic trading, the space where adaptive play, the Financial Information Exchange Protocol, or FIX, is king. Many traders will use terms based on the names used in the FIX protocol. As someone who wants to keep my executable specifications clean of the technicalities, this presents something of a dilemma. Is FIX part of the problem domain or part of the solution? In this case, I think the answer is probably both, if I am being honest. So I'm okay with exposing FIX here. I think it's a reasonable way of capturing the problem. I would be wary of doing that though if FIX was any less pervasive than it is in these sorts of trading scenarios. And I confess that when I was doing a lot more work in finance than I do these days, I opted for the other course, to use non-technical trading language to express the scenarios. Even so, if you know anything about trading, have ever worked in a trading environment, even in non-technical roles, I think that the chances are that you would be able to understand this example. I like this one quite a lot more than the previous one for this reason. We're placing an order and we can see the details of the order. The responses that come back are clear and mostly described from the perspective of Bob, the trader. I will quibble a bit over when FIX middleware session sends something or other. Traders don't know or care about middleware or sessions, but the next bit, they do care about execution reports, so that part is fine. My quibbles aside, I think that these examples are very good. Real-world examples of how to do a good job of BDD style acceptance testing. They aren't perfect, but they are good. I would abstract just a little bit more, and I think that that would give me a bit more freedom to scale up. and to generalize my test cases. In fact, in adaptive circumstances, I could imagine suites of canned test cases that I could pick off the shelf to capture the specification for the system that my clients were describing to me. The people at Adaptive are friends of mine and have been unfailingly open, supportive and helpful in making this episode. And so I hope that they will accept my thanks, in particular for being generous enough to allow me to critique their excellent work in public as a chance for all of us to learn from one another. There are some interesting links in the description to read more about what Adaptive and Hydra are doing and how that works. There are also links to the LMAX architecture and the Reactive Manifesto, both of which informed Adaptive's thinking to some extent. Finally, there are also some links to the open source project Aeron, the world's fastest messaging system, another LMAX inspired product, which forms the base layer of technology on which Hydra is built. This form of acceptance testing is the starting point for development. It allows us to be clear and precise about what we want of our systems. And it allows us to use the results of this thinking, the test cases themselves, to guide our development and show us when we're finished. These tests shouldn't be the only ones that you write. You need other kinds of tests too if you want to do a really effective job. But these executable specifications are a fantastic tool to guide our development. Thank you very much for watching.